Hello everyone, what's up? How you doing? Today it will be the session 2 of the Airbnb application development on Hedera, okay? Today we will discuss a very important topic which is the smart contracts and we will develop them together. And yeah, in case of you forgot, we are developing the Airbnb use case on Hedera from scratch together, guys. So please, if you have any question, don't hesitate, put them on the comment or DM me on my social media. I'm very responsive. So yeah, without further ado, let's start. Before we jump in, I have a question for you guys. Have you ever wondered why we pay 15 to 20% in fees like when booking a vacation rental, for example, or something like that? Like, think about it, that's hundreds of dollars on a typical booking going to a middleman. Okay. So, what if I told you we could eliminate those fees entirely? We could keep them if we want. Okay. But that's our call. Okay. And all of that while like actually making the system more secure. That's exactly what we are going to build today, guys. Together by the end of this video, you will understand how to create a fully functional decentralized property rental system where properties they are represented as NFTs, which is cool. NFTs that you actually own, okay? Bookings, they are handled through smart contracts, escrows, and everything runs on Hedera's Lightning Network, which is something very, very cool. So, without making longer introductions, let's take a deep dive right now. So, yeah, as you can see in this slide, our Hedera Airbnb system consists of two main smart contracts working in perfect harmony. First, we have the NFT creator contract. This is where the magic begins, okay? This contract handles the tokenization of properties. Every property becomes a unique NFT, which is something cool, with its own metadata and availability calendar, okay? Think of it like instead of having property listing in a centralized database, controlled by a company. Now, each property exists as a sovereign digital asset on the blockchain that you own. Okay? So that's even better. The second contract is the Hedera States escrow contract, actually, and this is our trust layer. When someone wants to book a property, they send their payment to this escrow contract, and the money sits there, safe and secure, until the property owner approves the booking. Okay, so if they approves, the money goes to the owner and the dates get marked, of course, as booked. And if they reject, the money automatically returns to the guest. No disputes, no chargebacks, no customer support, nothing. Okay, the code in here is your customer support, which is cool. And yeah, let's go now. Here's where it gets really interesting. Let's go to the next slide. In traditional system like Airbnb, you're like you have it like you have in this picture, you have multiple points of failure. Okay, the company's servers could go down. Okay, and payment processors could have like issues, and the company in itself could change its policy or even go out of business. Like it happened. Okay, in a lot of companies. And your data, your booking history, your reviews, they are all controlled by one entity. But in our decentralized system, the DLT or blockchain or whatever, is the database in here. It's running multiple nodes worldwide, no single point of failure. Your property NFT, you truly own it, okay? Which is cool. And you can sell it, you can transfer it, you can even put it as a collateral if you want to take a loan. I know it's not maybe the perfect use case that we are doing right here, but it is possible. Like the possibilities, they are endless. You could lend it, for example, okay? If you are a property owner, okay? So we could talk about these use cases after that, but you see the potential, guys. And here's the kicker actually. We are building this on Hedera and not Ethereum. Why does that matter? Let me break it down for you. Creating an NFT on Ethereum costs anywhere from 40 to $200 like in gas fees. And that depends on the congestion of the network, okay? On Hedera, less than a penny. That's the big difference. Like, let's say we want to transfer this NFT on Ethereum. $5 to $20, everybody, okay? In gas fees. On Hedera, like 1/10 of a cent. And while Ethereum transactions like sometimes they take minutes to confirm. Hedera gives us finality in 3 to 5 seconds. Okay, not even minutes. Okay, it's very fast. It's very cheap. Everyone love Hedera. Everyone like wants to build on Hedera. Okay, and that's why Hedera is the perfect background for our use cases, especially the Hedera Airbnb use case that we are developing together, guys. So, all right, let's deep dive into the code right now, and I'm going to walk you through the NFT creator contract line by line, and I promise. Don't worry, guys. Even if you are new to Solidity, you will understand exactly what is happening. Okay, it's very simple. It's very easy. So first, look at the contract, guys. This is the contract declaration. The first line, like the contract NFT creator is expiry helper. Okay, and here we are inheriting from expiry helper, which gives us utilities for managing tokens expiration, and this is important because on Hedera, tokens can expire if not renewed. Okay? So we handle this automatically. Now, the really clever part looks like like this. Okay? So look at this mapping, okay, that we have in here. Mapping address, mapping in64 to mapping UN256 to boo. Okay. This seems like a little bit complicated when you read it, okay? But trust me, it's very, very simple, and I will break this down for you because this is the heart of our availability system, okay? The first mapping is a triple nested mapping. It goes token address to serial number to date to boolean, okay, indicating if it is booked or not. So think of it like is if you have like a giant spreadsheet, okay, each property collection have its own sheet. Each property in that collection has its own row, okay, each date has its own column, and each cell like we have either available or booked. But instead of a spreadsheet that could be hacked or deleted, this lives forever on the blockchain, okay? And this is like the way that we write it with code. So it looks complicated, but trust me, as I explained it for you, it's very, very simple. Okay, it's a table after all, okay? So yeah, now let's look at the create NFT function, okay? So this is a very important function because obviously this is the function that will make you able to create an NFT, okay? So as you can see in here, function create NFT, string memory name, string memory symbol, string memory memo, string in 64 max supply, in 32 auto renewal period, and external payable with us address. Okay. I mean, when I read it, it seems very obvious to me, to be honest. Like this function like creates a new collection. Like when you see the parameters, I think you already guessed what the core function is. So like this function, it creates you a new collection of property NFTs. Okay. So let's say you own multiple beach houses in Miami. Okay. You'd call this function wants to create the Miami beach houses collection. Okay. So the name parameter would be Miami beach houses, for example. The symbol might be MBH, okay? And you'd set max supply to however many properties you plan to tokenize or you plan to buy. Inside the function, we are setting up the key tokens, which is this part, okay? This is crucial. We are setting the contract itself as the supply key holder in here. This means only our contract can mint new property NFTs, okay? So no one else, not even you as the deployer, can mint tokens outside of this contract's rules, okay? That's a security feature. It is not a bug, guys, okay? So it's very important that it's only this contract and not other contracts, okay? Because this contract, and actually there is a meaning why it is called contract, not code. Contract because it contains rules, okay? And here we have our own rules, and we need to go by the rules if we want to use this application. Next, we configure the token properties, and this is like the fun part of the function. Token.name, name, token.symbol, symbol, token.treasury, address this, which is this smart contract will be this address on the smart contract will be the treasury, token supply true, token.max supply will take the parameter. So notice that token supply type is set to true, making this infinite supply token. This is important for scarcity. If you say there are only 100 beach houses in your collection, something like that, there will be only ever be 100, no inflation, no dilution. So the actual token creation happens in here. Okay, so this part, Hedera token service dot create non-fungible token and takes as parameter the token. So we're calling Hedera's native token service. This isn't an ERC 721 implementation. It's native to the platform, okay? Which means it's more efficient and cheaper to operate. And by the way, guys, if you have some Solidity knowledge, okay, or Ethereum knowledge exactly, you need to unlearn them a bit, okay, because Hedera and Ethereum, they are very, very different from each other, okay. It's the same programming language. It's cool to have it. It will help you, that's for sure. But you don't need to compare them a lot. They are very different from each other, okay. So yeah. Let's go now to the mint function, is where individual properties come to life, and this is the mint function that we have in here, and this function does three critical things. First, it mints the actual NFT with its metadata. The metadata could be an IPFS hash pointing to property photos, descriptions, everything you want, okay? So and second, it assigns a unique serial number to this property. And third, this is the clever part. It initializes all the available dates for this property, okay? As you can see. So look at this loop, guys. Look at this loop that we have in here. Yeah, I don't blame you if when you read it first time you think it's Chinese or something like that. Yeah, it looks very, very complicated when you see it, but trust me, it's not like hard because we are adding we are like using our first mapping that we declared, okay? So it's a triple nested mapping, but it's not hard, guys. It's not hard. Just follow the brackets, you will get it, okay? So for each date the property owner says is available, we are marking it as false in our availability mapping, okay? So remember, false means available, true means blocked. It's like counterintuitive, but it makes the logic cleaner if you think about it, okay? So we're also maintaining an array of all days for easy retrievals, and the security in the update availability function is worth highlighting, to be honest. I will go to this function, the update availability. As you can see in here, we are like querying the Hedera token service to get the current owner of the NFT. Okay, only the actual owner can update availability, as you can see in this slide. So this prevents anyone from maliciously marking properties as booked when they are not. Okay, so it's very simple. It's simple security. Okay, if we go now to the escrow contract, let's go to a deep dive on that. That's the second smart contract, and it is very important as well. So now let's move on to the escrow. So this is where the money flows. So pay close attention, guys, because this is where security is absolutely critical, guys. Like any single point of failure could go south. Okay, so focus in this part is very important. So the contract starts with a struct that defines what a booking looks like. This is the structure. Okay, you can see it as a class or something like that. Okay, so um, as you can see, address renter, address property owner, union 256. I'm sorry, token ID, start date, end date, amount is approved, is complete, and is canceled. Okay, so every booking has these 9 pieces of information: who's renting, who owns the property, which property, and when does it start and when does it end, and how much are they paying, and 3 Boolean flags tracking the booking status. Okay, cool. Let's walk through a complete booking flow, starting with request booking, the first function. Yeah, that's the function. And here, when a guest finds a property they like, they call this function and send their payments along with it. So that's what the payable keyword means, actually, okay? Because this function is ready to get money, okay? So this function can receive each bar. So first, we validate everything, okay? We have the three requires that we have first. That's the the conditions, okay, the conditional part. These checks prevent obvious errors, of course. You can't book without paying, you can't have an end date before your start date, and you can book dates that have already passed, okay? So yeah, that's the three conditions. But here's actually the important check for you. And yeah, this is the loop that I'm showing you right here, which we are checking every single day in the requested range. If even one day is already booked, the entire transaction fails. Okay, so this prevents double booking at the smart contract level. No human intervention needed. That's cool. So if all checks pass, we create the booking. Okay, and this is the part of the booking creation. So the money is now held in the escrow contract. It's not in the gas wallet anymore, but it's not also in the host wallet yet. It's in the limbo, okay? Waiting for the approval, okay? It's in the escrow, it's waiting. Okay, so it's secure. So it is like the middleman here. So now when the property owner sees like this transaction request, they can approve it, okay, if they want. So this is the approve booking function. First, we verify that the person approving actually owns the property right now. This is very important because the NFTs can be transferred. We don't want someone to approve a booking for a property they sold yesterday, for example. Won't make sense. So if they are a legitimate owner, we mark all the dates as booked in this part. Okay. So, and then the moment of truth, we send the payment to the property owner. Okay. So, next, this is like using Solidity's low level code function to send H bar if you see it in here. If the transfer fails for any reason, the entire transaction reverts. So the dates go back to being available and the money stays in the escrow. But what if the host doesn't want to accept the booking, okay? That's where the reject booking comes in. So if you could read this function, the reject booking, it's very simple and clean. If you read it, you could understand it instantly. Like the money goes back to the guest, the booking is marked as cancelled, and the dates remains available for someone else to book. Simple and clear. So after the stay is complete, either like party can call complete booking, okay, which they can call this function, and this creates an immutable record that the stay happened, okay? In future version, this could trigger review systems, for example, or loyalty points, or other post-stay features or something like that. So one thing I want to emphasize, like, notice how we are changing state before making external calls. That's the check effects like interactions patterns, and it prevents reentrancy attack. We mark the booking as approved before, like sending money, not after. This is like very, very, very crucial for security. Okay, so like I'm glad that you focus on this, guys. So yeah. Now we finished the smart contract. Let's talk about what makes Hedera special for this use case. When you go create no fungible token, you're not deploying a new ERC-721 like you would on Ethereum. You're using Hedera's native token service. You see, it's very different, guys. So, like, as you can see in here, address, constant precompiled address equals to address 0x167. This magical address 0x167 is where the Hedera token service lives. Okay, it's a precompiled contract, meaning it's built into the platform itself. Okay, it's optimized at the protocol level. Okay, every operation returns a response code. Okay, so that's why we are putting in here if response code uh different from Hedera response code taxes, then reverts it failed or something like that. So instead of just reverting with a generic error, Hedera gives us specific codes like in order to put on the login. Okay, so token not found, that's code 167. Insufficient balance, code 10. This makes debugging so much easier, guys. And here's like something unique to Hedera token association, okay? So Hedera token service dot associate token receiver token in here, where an account can receive a token it must associate with it. Okay, this prevents token spam on Ethereum. And the last session, by the way, I showed you how my Solana wallet is like overly crowded with trash NFTs that I have, and I don't even bought these NFTs. Like random people sending me these NFTs, and they probably could contain like a scam or something like that, which is something not cool. On Ethereum, anyone as well can send you any token. On Hedera, you have to opt in first. Okay, like some people see that that's a little bit boring, it's a little bit like cumbersome, like that I need to like to do a step further, but trust me guys, on security basis is very good. Okay, so it's having like a spam filter Hedera like built into the chain itself, so that's cool. Let's go to the auto renewal feature is also unique. So token expiry tokens on Hedera like can expire to prevent bloat. Okay, but by setting an auto renewal account, like the contract itself and period, like we ensure our property NFT stays active as long as the contract has H bar to pay for storage. Okay, so that's very important. Now, guys, all right, let's me show you the actual deployment process using TypeScript. And this is the moment of the truth, like we say it, and we will be using the Hedera SDK. And this is production ready code, not pseudocode, guys. Okay, so first set up your environment, create the .mv file, your Hedera testnet credentials like the operator ID, put the operator key, which is the private key, and the receiver address. Okay. Now let's walk through the deployment flow I've created with TypeScript services that wrap our smart contracts with the Hedera SDK. Let me show you your deploy nft.ts script. So as you can see in here, this part, yeah, this creates our Hedera client. Notice we're using like the official Hedera SDK, not Web3.js or something like that, or Ethers for Ethereum. And this gives us native access to Hedera features, which is cool. So step one, deploy the NFT contracts. Like focus guys, it's very, very easy and very similar to Ethereum. Like not very similar, but like the steps like they are similar. Okay. So in here, like const NFT service, new NFT service, etc., etc. So the NFT service handles all the complexity for deployment. Like it compiles the contract, create the transaction, and returns the contract ID. Okay. Step two, create the token collection. Okay. So this returns an EVM compatible address. Hedera provides both native IDs and EVM addresses for interoperability. Step three, we mint a property NFT with availability dates. So in here, we will need to put parameters. See how we're setting up the availability calendar, guys, right at the mint time. So each date is a Unix timestamp, making date math simple. Okay, so yeah. Let's go to the next part, the const associate tokens TX. So before anyone can receive this NFT, they must associate with the tokens. This prevents token spam and gives us like give users like control for like for the NFTs. And now let's deploy the escrow contract. Look at the deploy escrow.th right now. The escrow, yeah, in this part, the escrow service, like the escrow needs to know the NFT contract address, obviously, so it can verify ownership and update availability. And here, like, where it gets really interesting, the complete booking task flow, like look at test escrow booking.ts. This simulates a real world scenario, guys. Okay, so create test accounts for guests like guest one, guest two. We are creating actual Hedera accounts with balances, and these could be real users in production, of course. And guest one will makes a booking, okay, and he like in this function like await escrow service that request booking, and we are calling the function, and the booking ID is returned immediately. Okay, the payment is now locked in the escrow, and we can check the booking details. Okay, cons booking details. Okay, while console logging. Okay, so the owner approves guest booking. Okay. And next we have the escrow service approved booking. So that triggers the payment transfer and make the dates as booked, as we explained earlier, guys. And we can verify the cost is available. Okay. For guest two, the owner decides to reject, for example. Okay. The money automatically returns to guest two, not guest one. Okay. And the days remain available. All of the information gets saved to JSON file for reference, okay? And cost deployment info in here, so to run this yourself. But actually, let me give you the opportunity, guys, to download the code down below in the repository and try it for yourself and deploy it using the deployment scripts and tell me if the tests they are running for you or not. For us, for this video, I will leave it to the next session for the implementation. The next session will be implementing these functionality within the front end, and we will see how they will behave. Thank you so much for following, and goodbye.